All right, so for part 4 of our discussion of means of samples, again, I don't have any idea how many of these there's going to end up being. We're gonna do it till we get it done. I'm going to show you a visual to help you understand this. This is not a software I'm requiring you to learn how to use. It is just a fun thing. Probably not that fun, but it's an interesting way to visualize some of these statistics. So you should be seeing my screen right now. This is on a website called Online Statbook if you're ever interested in playing with it. But let's go back to our example of that anxiety test that we did. Okay. The question we were asking is, how do I know I'm not just going to get a group? I couldn't just go through my 100 students, draw groups of 30, and get one that naturally had reduced anxiety. Like, how do I know that my intervention was effective? And the answer to that lies within some, it's part of the hypothesis test of means of samples. I was going to introduce more terminology, but no one needs that right now. All right, so what I've done here, this first one, I have gone through and just absolutely made up what we might see of these 100 participants and how they scored on this anxiety scale. All right. So maybe we had a few down here that are at the bottom. No, I'm not anxious. I feel great. I have a good routine in place. I know how to cope. I have good skills. I'm good. I'm no anxiety. We have some that are on the mild to moderate anxiety. Maybe we have a peak of severe anxiety. It goes down, and then maybe we have a few over here that are at the extreme. Okay. Again, totally made this up, but let's imagine this is what our data looks like. Now, what I want you to see here, and this is not a calculation you'll ever do, this is purely theoretical. The idea of means of samples is I can tell my data set, I want to see what the mean would be if I selected 20 random people. That's what I'm going to do first. Right here, n equals 20. So I select 20 random people. It pulls out 20 from here. And the mean is here. And now it's going to go down here and do this one of 25 because I'm going to make a point that the bigger, the different effect. Now, what's going to happen if I keep doing this? Let's say I do this 5 more times. Okay. Let's say I do it another 5 times. Let's say I do this sample where I'm drawing 20 students and taking an average of their scores, a mean of their scores. Say I do it 10,000 times. What do you notice? The mean of all of my samples that I took, the mean of all of my means that I took is really close to my population mean, right? 12.67 to 12.68, 12.68. This one's the same. They're the same. That means that if I'm drawing samples out of my data and I'm getting their mean, the more that I do this, eventually the mean of my distribution of means is going to be the same as my population mean. Okay. The more means that I take, the more groups of 20 students that I pull an average and keep adding that result into my graph here, the more this is going to get me where my samples are conforming to the overall population average. And that is how statistically, theoretically, I can have the confidence to say, all right, so if I compare the average of my group to the overall population average, this is a meaningful comparison, because if I was randomly taking samples of 30 students, they would be coming together to look like the overall population average. We'll work through the formulas in the book for that, and we'll work through the 2 examples with that to help that become more clear.